Hey there, last video we saw how to find the two missing sides. We were given one angle and one side. This time I'm going to just give us two sides. Let's say this is 10 and this is 6. And I need to find everything else, all the other angles. And you might say, well, this is 90 degrees. So if you find one angle, you can pretty much find the other because you know that the sum of the angles of a triangle is 180. And I say, yep, you sure can, just like you could check with Pythagorean. This would be a great way to go back and check your work. Okay, so let's go ahead and I know that we can find this using the Pythagorean as well, but we're not going to do that. We're going to do it using trig. Okay, so let's start with this one. What are we given? We don't know what angle is, so it's question mark. We're going to find the angle first, so that way we can have our, sines and cosines, and we can use that as well. So I'm going to use this to figure out what this angle is. I have been given if this is the angle, which is our target at this point, I could have picked that one, doesn't matter. If this is our target, then obviously this is our opposite, which we don't have, and that's our adjacent. And that's our hypotenuse. And so if I'm looking for the angle and I don't have the opposite, I'll put that down here. I have the adjacent, and the adjacent is 6, and I have the hypotenuse, and the hypotenuse is 10, and I'll quickly write our SOHCAHTOA things up here so you guys could see it real quick. And then it's a good thing to have this in front of you so that you could just, boom, look at that and use it for figuring out what equation you need to use. So here we see we have theta, adjacent, hypotenuse. So we could pretty see that this would have to be the one we're going to use, right? Theta, adjacent, hypotenuse are the things we're looking for. So I say, okay, cosine of theta must equal 6 over 10, right? Adjacent over hypotenuse. And now I need to find theta. What do we do? Well, when you had something like x squared is equal to 16, how'd you get rid of the x squared? You square rooted both sides, right? I killed that and got you the x out being a plus or minus 4. So we kill the square with a square root. How do you get rid of cosine? Well, remember that this is the inverse of that, right? The inverse function, like addition is the inverse of subtraction, multiplication is the inverse of division. So the inverse operator is what we use to get rid of these things. So how do we get the inverse of cosine? What is that? Well, we have a function which is called cosine inverse. You could write it like this, cosine inverse, or sometimes some people write arc cosine, which means the inverse of cosine. And so what we do here, looking at our equation, we want to get the theta out of there. So I have to do a cosine inverse to both sides. Remember that the rules of algebra, everything has to be done on both sides, or this equal sign is no longer valid, and everything breaks down. And so I will take a cosine inverse of this guy and a cosine inverse of this guy. So it's just a cosine with a negative 1 on top of it. But it's not the same as 1 over cosine, okay? So don't confuse that with the a to the minus 1 as 1 over a. Okay, this cosine inverse is a way of writing inverse, but it's not like writing that, so be careful of that. So here, that gets rid of our cosine. That's what we're looking for, right? So theta is equal to cosine inverse of 6 over 10. And you might say, well, what do I do now? Well, just your calculator does the rest. Back in the old days, we'd have tables we'd have to look up, but now it's nice and easy. It's all programmed in here. So I say I need to find, and here's the cosine inverse key which is just above the cosine with a, see the -1 there, to the -1 power? It's not the -1 power, but it looks like it. That is the key you need. To access the blue ones up here, you got to use a second function. So I'm going to say cosine inverse. So you see how that inverse popped up right there? Of 6. And of course, I could have made that 0.6 because I know what that is, but I could just write it this way because numbers might not always be that easy. And I hit enter, and there's my angle. So this angle here is 53.1 degrees. Okay? And so it'd be pretty easy to calculate that angle now, right? I could pretty much see it'd be 90 minus 53.1. So, yep, that's how you find the missing angle. I'll do a second video where we could maybe just look and see how to find the other missing angle.